Find the volume of the solid obtained by rotating the region bounded by the parabola x equals y squared plus 1, the line x equals 3, about the line x equals 3. We always draw a picture. When we draw the picture of the bounded region, make sure to remember that the x and the y axis are the help lines only. They are not part of the bounded regions unless stated otherwise. For example, in this case, when we grab x equals y squared plus 1 and x equals 3, we see that there is a bounded region between the two curves. And that is the intended region bounded by the parabola and the line. Per the problem, we then take this region and we rotate it about the line x equals 3, which is a vertical line. And when we rotated this region about the line x equals 3, we form a solid. And we're interested in the volume of this solid. Note that the axis of rotation is on the straight boundary. So when we rotated the region about the line x equals 3, there is no hole in the middle. And if there's no hole in the middle, then we would use the disk method. Using the disk method, we will slice the solid perpendicular to the axis of rotation. Thus, the thickness is delta y. We then draw a representative slice. The volume of this slice is pi r squared times the thickness, which is delta y. The variable of integration is going to be y, and so we would need to express the radius r in terms of y. We always label the intersection of the cross-section with the curve at the point x, y. The horizontal distance from the origin to that point is x, and the vertical distance from that point to the origin is y. But the radius is from the point x, y to x equals 3. It is the horizontal distance. Therefore, the radius is the right value, which is 3, minus the left value, which is always x. For example, if we were to draw another cross-section, then the radius would be the right x equals 3 minus the left, which is an arbitrary x. Because of the delta y, we will need to express x in terms of y, but x is y squared plus 1, and so the radius is 3 minus y squared plus 1, or simply 2 minus y squared. The volume of each slice is pi times 2 minus y I squared times delta y. The total volume is the Riemann sum pi 2 minus yi squared times delta y at I go from 1 to n. As n go to infinity, we obtain the exact volume in the form of the integral pi 2 minus y squared dy. We add up these horizontal slices from lower to upper, from y lower to y upper. These are the limits of integration. To find these limits of integration, we set the equation x equals y squared plus 1 equal to x equals 3. And we solve for y. Y squared is 2, and so y is plus or minus the square root of 2. The lower limit of integration is therefore minus the square root of 2, and the upper limit of integration is positive the square root of 2.